It is, by my clock back here, 12:45, and we're going to get started. Before we do so, the standard announcements we always make before programs in here. Your exits are either over to your left through that archway. There's a door that takes you out to the main hall. Or if you come back over to the right, over here where you came in, is another exit that will bring you back in. And if I could get a volunteer to run over there and close that inner door, I would greatly appreciate it. That will help us a lot during the show. Just kick the wedge out and let the inner door close there. Okay, at this point in time, I'd ask that you turn all cell phones on silent or vibrate. We'd also ask that you keep those up during the program, as the light from the display will show up on the dome and affect the quality of the program. Last but not least, everything's going to take place in the blue area over your head. The seats do recline and you can push back and get comfortable. We do ask that you be aware of where your feet are at and not put them up on the head of the person in front of you or up on the seats. We just want to keep them as nice as possible for as long as possible. Now, with that said, we're going to get started with the program today. Professor Twiggs was just wanting me to run through a few demonstrations of some orbits that we're able to do here in the Star Theater. So with that, I'm going to take down our blue cove lights and bring up our evening sky here. Actually, it's our daytime sky. And I'm going to run, from this point, I'm going to go ahead and just lift us off planet Earth. This will take just a few moments to do. So here we are looking down at planet Earth. I'm going to do a little bit of a roll and get us in a more north oriented situation, something you might be more familiar with there, a view that just may seem more normal to you. And we'll stop about right there. If we peel back the atmosphere and the clouds, you can see North America there, down to there's Florida, over to Texas, the Baja Peninsula, up California, and Alaska. It would still be night up here in Alaska. You can also see the northern part of South America right down here. Now, when we talk about orbits, we want to look first at objects that are very close to us. And to make this a little more realistic, I'm going to put just a tiny bit of motion in on the clock. So we're going to get the Earth slowly turning there, and the clock's going to move ahead. And we're going to start by bringing up some of what we call the visual satellites, or the low Earth orbiting satellites. Now, we can mark their orbits here, and you can see some of them have polar orbits. They go north to south, south to north. Some have some equatorial type orbits. Some are close to circular, while others are a little more elongated. Let's take their orbits away. To that, in these low Earth orbiting ones, let's add some CubeSats. We'll populate some CubeSats out there. We can show their orbits there. We'll also add, in the low Earth orbiting group, the Iridium satellites. So this is part of a satellite telecommunications network that was started several years back, but was not commercially viable. And I believe the military has taken this over and is using it now. But it's a satellite phone system. So we'll take the Iridiums away there. The satellites are still there, but the orbits are gone. And we're going to add amateur satellites to this. And we'll back away from Earth just a little bit, because some of these amateur satellites have a little bit bigger orbits, some a little more elliptical than those low Earth orbiters that we were seeing. And there's a whole group called educational satellites. We'll put those up there as well. and you can see those. I believe that the CubeSats are in those orbits. But mostly, these are all LEOs. And what altitude are LEOs at? And you got to shout it out kind of loud back here because it's hard to hear back here at the operator's desk. You know, your lowest LEOs can be as high as, you know, 100 miles, maybe a little more than that. Yeah, so when you move back a little farther, you start getting into what are the MEOs, or the middle Earth orbiting satellites, and our best samples of these are the GPS satellites, and we'll turn their orbits on. Now, GPS, these guys go out about 1,200 kilometers, somewhere in that range, and they're in constellations. You know, you've got to see at least 3 of these for your GPS unit to work, it's the more the better, the tighter fix you get, but you've got to be able to see at least 3 of these above the horizon, or your GPS just does not work. So that's the GPS. Now, included in these kind of MEOs are a strange group. These were developed by the Russians, and they're referred to as the Molniya orbits. And we'll put them in here and bring up their orbits. Did Professor Twiggs talk to you about Molniya orbits? Was that a yes or a no? Yes. So you can see it's kind of a tulip-shaped pattern, and the whole idea behind these orbits was to give them long linger times over the northern hemisphere. So as a satellite, let me do a little rotation here. If I do this and just try and get kind of a side view of one where we've got a good view here, something like this. So if you've got, the satellite's going to have its fastest speed here, but as it climbs up to its high point, it's going to slow down. It's going to have a lot of linger time here where it can look down at the northern hemisphere, all while it's climbing up and starting to come back down. And then it's going to speed up. Well, who wants to look at the South Pole? The Russians wanted to look at the northern hemisphere. They wanted to see what we were doing. They were wanting to see what was happening in Western Europe. They didn't really care about Antarctica. So these highly elliptical orbits gave them these long linger times over the northern hemisphere. Now, as we back on out, there's another group of satellites that are a little bit farther out. We'll take the Molniya orbits away there. And this last group are the ones that are out about 25,000 or so miles. And this is the GEOs. And we'll pause here for just a second and turn on the geosynchronous satellites. And you can see they make a nice little ring right here around Earth. We'll come in a little bit closer. They're above the equator. It takes them the same amount of time to make an orbit around the Earth as it does for the Earth to make a rotation on its axis. So they appear to hover over the same point on the Earth. Classic examples are Dish Network or DirecTV. That little dish just points at the same place in the sky and it never moves. Now, one of the things that you do notice, if I orbit around here a little bit and get out over the Pacific, you'll start to see the satellites thin out. Most of these constellations are set up over continents, but you get out over areas where there's not a lot of need for downlink, and the geosynchronous satellites thin out here. And then as you come back around and you start getting over continental areas, and let me do one thing here. Let me put full light on Earth, and that might help us see this here. Yeah, as you get over continent areas, then the numbers of geosynchronous satellites build back up. And if we mark their orbits, the computers start not to like it very much. And if you really mark them all, then the computer really doesn't like them. So anyway, we'll take away all these other guys here. Just too many data points. So these are the Earth orbiting satellites. And most of these are in either circular or elliptical orbits or out at geosynchronous. But if we back out a little farther in the solar system, and as we do this, if we pause about right here, let's turn on the moon's orbit. That's about 240,000 miles out. If we keep going out farther, you can see the orbit of the Earth, and there's the sun. I'm going to pause for just a moment here in a second and center us up on the sun. And because that'll help us do what we're going to do here next. And that is bring in all these guys. So these are the asteroids. This is the asteroid belt. Now, what's so big about this? Well, when you start talking about orbits, one of the things to note is right here is the planet Jupiter. Right there. And if I click on Jupiter and make him a little bit bigger, so you've got him there. One of the things to notice is there's a group of asteroids that follow Jupiter, and they precede Jupiter through its orbit. So if we do this, and give me just a second here, kind of brighten them up. These are the Trojan asteroids, and they occupy Lagrangian points between Jupiter and the Sun. So they occupy the L1 and L2, L3 and L4. I'd have to check that one again. That they always confuse me. But these asteroids, one group precedes Jupiter in its orbit, and the other group follows Jupiter in its orbit. And they are in Lagrangian points between Jupiter and the Sun. So you've got these guys here. And if we continue on back a little ways, let's pause for just a moment. And let's bring those guys back down to a more normal size so they don't look so huge. And matter of fact, let's take the asteroids away. The other orbiting objects that we have in the solar system are the comets. And if we really crank up the clock here, and get them moving, what you'll see, as some of them sweep in close to the Sun, you'll see them get ejected out. So watch for ones that come in and make really close passes to the Sun. And you'll see watch this guy come in right here. And he went right past the Sun. But you can see a lot of them come in, they'll make a quick swing around the Sun, and they'll head out. So these guys are mostly on elliptical orbits. Comets are broken down into two groups. Short period comets, comets whose orbits are under 200 years, and long period comets, comets whose orbits are greater than 200 years. The long period comets tend to come from farther out. They come from either out here in the Kuiper Belt at the farthest reaches, or even out in the Oort cloud, which is about 1 light year out from planet Earth. Now, let's take these guys away here, and let's stop the clock moving forward here. And one of the things I want to bring up is the 1 light month grid here. Give me just a second. So as we back away, this grid that you're starting to see represents a light month, how far out light travels from Earth in the period of 1 month. And each of these inner concentric rings is 1 day until you get out to the 7-day period. Then there you can see 2 light weeks, 3 light weeks, and 4 light weeks. And to that, we can add the light year. Okay, so this is out about 6 trillion miles. From the sun out to the outer edge is about 6 trillion miles. The reason I show you this, if we turn on 2 other grid lines, the 10 light year grid and the 100 light year grid, and we back on out a little farther here, I'm sorry, the 10 light year grid, I meant to turn on the 100 light year grid and not the 1,000 light year grid. So let's get back in here to about 100 light years out. And let's pause about right here. And let's turn on the radiosphere. So this is about how far out our transmissions have made it into space since we've been, it's considered transmissions that are still strong enough to be decipherable. We're out about 65 to 70 light years out. And if I turn on the exoplanets, now you're starting to see where stars are that have planets that are around those stars that we have discovered outside of our solar system. Unfortunately, all the planets that I'm aware of that have been discovered inside the radiosphere are all Jupiter-like planets and not capable of supporting life. Now, Kepler's doing some great work looking for Earth-like planets, but I think they've got a candidate right now they're looking at really hard. But if you look here, you'll see that there's not a lot of planets around stars even within 10 light years of our home world there. So where's all this going? Well, let's do a couple other little things here. And let's get at an angle about right here. And let's kind of fly in, and let's take some of this other stuff away. We'll take the radiosphere away, and we'll take away the 100 light year grid and the 10 light year grid. So you can see there's no stars with planets within 1 light year of planet Earth. So we'll take away the 1 light year grid, and that leaves the 1 light month grid. And we'll scroll up here. We'll take the exoplanets away. And as we get close, you're starting to see some lines here. I've put in the flight paths of Pioneers 10 and 11 and Voyagers 1 and 2. All 4 of these spacecraft were launched in the mid-1970s. We flung them out from Earth about as fast as we could at that time. They've been traveling for 40 years. And notice that they've just barely made it a light day out from planet Earth after 40 years of travel. I get a lot of questions here in the planetarium. Mr. Thomas, do you believe that there's life out in the universe? And my answer to that one is yes, I do believe there's life somewhere out in the universe. If not, I think it's a great waste of space. Then the immediate question that follows is, well, do you think there's UFOs that have come to Earth? And I typically say no. Just by looking at this and our understanding of physics as it is at this point in time, I don't think that we've had visitors from other planets come here and do experiments on our fellow citizens and mutilate our cattle. So this is just to kind of give you an idea of how far out we've gotten. Now, the other thing you can take from this is you can look at these flight paths, and if I take away the 1 light month grid there, you can see how NASA used the gravity of these planets as they launched these spacecraft to change their flight paths. So they go out a little ways and they make an orbit around a planet. It changes the flight path, puts them online for another target. And there you can even see the dates of when these occurred. Now, one last thing, let me get Jupiter back down to its normal size. As we get back in a little bit closer to Earth, let's take away the Voyagers and the Pioneers, and let's center up on planet Earth here real quick. Sorry about that fast turnaround there, but we'll get in real close. I got one last thing I want to show you here. So there's the orbit of the moon. Here comes the Earth, and all that is the junk that we've left in orbit. Those are dead satellites. Those are nuts and bolts. Those are boosters that no longer operate. So if you take that and you add to it all the satellites that are working, you get a very cluttered area up there. So all the red and yellow dots are junk. Okay, and with that, let's take away the space junk, and let's take away our satellites, and that is going to conclude what I had for you today. Typically, Professor Twiggs usually only brings this class in for about half the period. So, and that's typically what we do, is just a visualization of some of the orbits that you've already talked about. So unless there's specific questions, that's really all I've got for you.